Hello friends, myself Professor A.D.Gujar, working in a computer engineering department as an assistant professor in TSSM's Bhirabai Sawant College of Engineering and Research, Nare. Today I am going to give presentation on the software architecture and design. In this I am going to discuss on the following points. First is the software introduction to the software architecture and design. Next is the architecture in the life cycle, that is in software development life cycle. The third I am going to discuss on the designing the architectures, and fourth is forming the team structure, and the then last point, that is the creating the skeletal system. So, let us start with the first, that is introductory part, that is what is the software architecture. So, as already you know, software architecture is nothing but it is a blueprint, just like while building some while developing any building, first thing that is required, that is a blueprint for that building, or so similarly here in a software the blueprint for the any system that is required. So, software architecture, it is a blueprint for both the system and the project which it develops. So, now why it is necessary? Because when we are building any system, it has to achieve certain business goals, because any system when we are going to build, that should conform with some business goals, that should achieve with some business goals. So, this when the business goals are set, then these business goals are set and the architecture gets formed, and then that architecture will be converted into the system. So, this whatever system is developed, that should conform to the whatever the business goals or whatever the architecture that is to be designed. So, these are interrelated with each other. So, what the system that has been developed, that should conform to the business goals. No, so these things are very interrelated, and when we have to differentiate between the software architecture and the design. So, how can we differentiate the software architecture and the design? The software architecture that basically focuses on the skeleton or high level infrastructure of a software, means whatever the components are there, how they are put, or how they are interrelated with each other. So, these particularly components, how they are put and how they are interacting with each other. So, this software architecture that will focus on how the skeleton will be designed, or how the skeleton is provided. But what the design is basically focuses on the actual implementation, or at the most specific level, how that particular components that will function, and how they will, that modules or components, they will interact with each other. So, this is the difference. That means what the architecture is, it will be the this will form the skeleton, and the design that will focus more focus on the actual implementation or the modules which are there, and the coding part which that is need to be there. So, next thing is that in the software architecture and design, this particular when some system needs to be designed, that system should have some contributory factors, because unless and until these contributory factors are not there, the system will not be complete, and these contributory factors will make the system complete. And what are now these contributory factors? Let us see that different these factors which will affect any system. So, first part, that is the business strategy, what business strategies you have to achieve. Second, that part, that contributory factor which we have to consider is the quality attributes, what quality attributes needs to be satisfied by any system. The next contributory factor, that is the human dynamics, means what is going to affect on the human dynamics and how it is going to affect on a developed system. The next component that is to be affecting on the system, that is the design of that system. So, the design of the system, that how it is going to affect on the business strategy also, that also we have to see. And the last and the not least, but it is the IT environment, that is under which circumstances or what components are required, IT components are required to make the system work. So, these are the 5 contributory factors. So, we can see these contributory factors in detail. Now, first thing is the business strategy. In this business strategy, what we have to see is what the company should what the company has decided to achieve the different goals, meet the expectation of the customers and sustain the competitive advantages in a marketplace. Because every system, when some company is designing any system, it has formulated certain business strategy, it has to achieve certain goals, and for to achieving such goals it needs to follow certain strategy. That means how that strategy is going to work out and how they are going to it is going to affect on a design of a system. So, first thing is the business strategy which is applied to make the system work. Then next is the design. So, whatever the system has to design, this refers at the integrated planning process that examines relationship between how the design and business they are complementing with each other, means they are interrelated with each other, means whatever the design you are doing, that will naturally affect the business goals. Because if the design is good, the business will be good, the customers will is going to more focus on this particular component or system which is designed. So, this is the second contributory factor which we have seen. Then next is the what are the quality attributes which are necessary in the system. So, these different quality attributes I have mentioned here, like maintainability, testability, portability, flexibility, then reusability, simplicity, availability, so security, performance, then the concurrency, reliability, scalability, then lifetime of the system. So, these are the different quality attributes that needs to be there in a system, and unless and until these quality attributes are not there, any customer that will not purchase the system, or that will not take purchase whatever the product you have designed. So, this is the this is the contributory factor which is important. Then the human dynamics is the last part, but IT environment, in IT environment what is important is that what different components are needed, in a system, what components are required, or what are the let us say the servers are there, then different networks are there, then different switches are there, the workstations are there. So, all these components, IT components are there, what different components are used and how they are utilized, whether the cost is minimum, that also we have to see, also we have to see while designing the system. So, whenever you are utilizing or using these IT components, you have to see also the cost of development of the system. So, this is also is a very important factor, the contributory factor. Then the next is the human dynamics. Generally we see that human tendency or to utilizing certain system, how the human tendency is there. So, this particular component, contributory factor, has the 3 basic parts, that is the mental, emotional and the physical parts are there. So, how when the system has been developed or designed, or that how is essential, or how easily that particular system is there to handle by the customers, end users, many stakeholders are there which are utilizing the system. So, how they are going to they are going to make utilization of the system, whether and how much usable that particular components or part of the system, how they are familiar that system they are looking, that is very important. So, these are the contributory factors which are very important while we are designing any system. So, these 5 contributory factors we have seen. Now, we will turn to the architecture in life cycle. Now, already we are familiar with the software development life cycle. In software development life cycle, we know that first initially while designing any system or developing any system, first thing is that what idea is there, or what product needs to be created. So this software concept, what concept that is very important, or idea which comes in front of the developer, that is very important. And then according to this idea or the concept, the requirements are gathered, the requirements are collected, and then according to the requirements the architecture is formed, the skeletal system of the skeletal of the system has been formed. And then the after the skeleton has been formed, then the first preliminary version, we can say a beta version, that has been launched. This version which is launched, that will be utilized by this particular users, or that customers. These customers will give certain feedback depending on how they feel while utilizing this system. And when this customer feedback is also incorporated into the system, then some changes has been made, and these changes has been made, and then the final version has been launched. So in this way, this particular life cycle goes on for a software, for designing any system. So this is how the architecture plays role in a software development life cycle. Now for one example I want to give here. So when suppose you want to design a security system, in that when you have to design a security system, there is one login form that has been created. So I have shown here a flowchart. That flowchart shows that when certain user needs to enter into the system, what is the input that is provided. That is, first is the login ID and or user ID and the password that is needed. But now we can see here from this flowchart that whenever it is correct, it will be allowed to access the page. But whenever it is not correct, then some secret question will be asked, and then that secret question, that will be, if it is this secret question is answered correctly, then the particular allowed access will be allowed for that user. So in this way, this particular design, from this example design for the security, we can understand how the design works. So these are the basically components that we can see in a system. So this is just an example which has been given for the security. Now what the architecture does, the architecture has a very important role while designing the system. So basically this software architect, it provides the solution that the technical team that create and design for the entire application, because whatever this architect will design, depending on the design, then and then only whatever the software developers or the technical team that will work on that particular module or that particular design what has been given by that architect. So this role of the architect is very important. This architect will give a proper design. It will put the proper component at particular places. It will give the particular specifications, and depending on that designer team that will try to build that particular implement that particular components. So this is the a very important role. Along with this, the architect should have the design expertise. It should have the domain expertise in which particular the system needs to be designed. That architect needs to have a proper knowledge of that particular domain. It should have the proper knowledge of the technologies, because whether a particular technology or particular language is sufficient, which different languages or technologies are available into the market, that also he has to see. And then he has to suggest the different options also for the particular design teams. So in this way, the role of architect is very important. So the whatever the quality attributes what we have seen, the quality attributes what the quality attributes we have seen, that quality attributes can be divided into two different basic parts. First, we can say some quality attributes are static quality attributes, and some are the dynamic quality attributes. So what are the static quality attributes? So static quality attributes, like for example, the modularity, the testability, and the maintainability. So modularity means whenever you design the system, the modules are there in a particular system. Different modules have been designed, small modules have been designed. These modules that will be that will be that will interact with each other, and that modules which are designed, that should be similar with each other. So this should be have some similarity, and they should be able to interact with each other. Some testability, whatever modules have been designed, that should be testable modules, that needs to be tested. Then the different strategies can be applied to test that particular modules. Then maintainability, so whatever modules have been designed in the system, that can be that maintenance of that module should be efficient. So these are some of the quality attributes which are the static quality attributes. Some quality attributes of a system are the dynamic quality attributes. In this dynamic quality attributes, what specifically we achieve is, we achieve the behavior of a system during the execution, means at the running, how this particular system is giving throughput or output for a particular input. So this is the throughput, then robustness and scalability. The system should be giving a proper throughput or output for a particular input. Then it should be robust, it should not crash at any particular level. And the scalability, that means whenever some system is in a small form, then it should be scalable. You can add more number of components into the system. So these are the different quality attributes that needs to be there in the system. Okay, thank you. Okay.